So we're going to use the angle addition postulate to find the following measures. Notice how when, in example 2, when it says they want you to find the measure of angle PRS, this little m out front lets me know that I'm going to be looking to figure out how many degrees big that angle is. So PRS, when I trace it, I trace along sort of the edge of the angle. So PRS is PRS. That means it's the whole angle. It's both of these pieces put together. So to figure out how big this angle is, I would take the 81 and I would take the 42 and I would add them together. So I'm doing 81 plus 42. I get 123, and then make sure you put the little symbol right here that's in the corner. This stands for degrees. So to find out how big this angle was, I added them together. On example B, I'm trying to find the measure of angle W, X, Z. So on this one, I'm trying to figure out just how big this piece of the angle is. I see the box in the corner, which tells me the whole angle is 90 degrees. I know that this piece over here is already 26. So I'm going to do 90 take away 26 on this one to figure out that the piece of the angle that I'm looking for is 64. So this was an add question because you were trying to figure out the whole thing. And this one was a subtract question because you were trying to figure out just a piece. Both are the angle addition postulate, even though you're using it differently in the second question. So for the next one, the last one in this example, it says the measure of angle NRQ is 78 degrees. So I don't know how big this piece is, NRP, and I don't know how big this one is, PRQ, but I know that both of them together add up to be 78 degrees. So on this one, I'm going to take the two pieces that they tell me. So I'll take 8x plus 7, that's the top piece, plus 4x minus 1, that's this bottom piece right here. And I know that they're going to add up to equal 78 degrees because the directions to the question said that they equaled 78 right here. And now this is an equation with one variable that's in two places. And so I'm going to go through and use what I know about algebra to solve to figure out the answer to this question. So I'll add up my x's that are over here on the left, and I'll combine my terms that are over here on the left. I get 12x equals 72, and when I divide both sides by 12, I'm running out of space, I'll write it right here, I get x equals 6. So it's fine to put a box around x equals 6, but it's also good for you to know that that's not the answer to the question. They want us to figure out the measure of angle PRQ. So I'm going to go back to my picture, find PRQ, and when I trace that, I can see that it's talking about this piece of the angle right here. So to find the measure of angle PRQ, I'm going to take the 6 that I just got for the x, and I'm going to plug it in right here for the x. So 4 times 6 minus 1, PRQ. So that's 24 minus 1. So I'll get that the measure of angle that's supposed to be a Q, the measure of angle PRQ is equal to 23 degrees. So that's the answer to the question that they were looking for. If the question said that they wanted me to figure out the measure of angle, let's see, the other angle. So if it said it wanted me to figure out how big NRP is, that would be the other one over here, I would do the same thing and solve for x, so I would still use the angle addition postulate, but then when I'm finding the answer to the question, I wouldn't plug it into this part, I would plug it into the other part. On a test or something like that, you could always plug the x into the other part and make sure that you got whatever the other number would have been. So in this case, that's 55. If you plug in 6 over here, you should get 55. And you're welcome to do that and just make sure that you get the same answer to the question. On example number 3, they give us this shape on the question, and they want us to find the measure of the following angles. So to do this question, I'm going to zoom in here a little bit because I want to make sure that you can see this picture nice up and close so that you can compare it to what you're writing on. Just give me a second to get this focused, guys. All right. So this half circle shape thing is called a protractor. And you're going to need one of these in the next couple of lessons in your math classes. So a protractor is usually clear. It's not very big, sometimes it's small. And it goes from 0 to 180 on the outside, and then it goes from 0 to 180 on the inside. So whenever you're measuring how big angles are, you want to make sure that you know whether you're looking on the outside or the inside and where you're starting. It's wherever you start at 0 is whether you're looking on the outside or the inside. So a normal protractor is a plastic or metal tool that you place on top of your paper. But for this question, they gave you the protractor typed on your paper, and they wanted you to just look at the angles and practice using the measurements to figure out how big they are. So the first angle they want me to find how big it is MLN. So M starts right here, L is in the middle, and then N finishes right here. So I'm going to look at side LM, ray LM of this angle, and notice that the 0 is on the outside. So if the angle stopped here, it would be 10 degrees big, not 170 degrees big. So this would be 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, and 60 degrees. So that's how I decide that the answer to this first question right here is 60 degrees. It's because I'm looking on the outside, not the inside. For the next one, for NLP, I'm going to look at my protractor. So NLP is kind of tricky because notice that NLP doesn't start or stop on the number 0. It goes from the number 60 over to the number 130. Or you can think about it that it goes from the number 120 down to the number 50. So the thing about a protractor is it doesn't matter whether you add or subtract the inside numbers or the outside numbers, you're going to get the same thing. So if you count it on the outside, this would be 10, 20, 30, 40, 50, 60, 70. And then if you count on the inside, it would be 10, 20, 30, 40, 50, 60, 70. You don't have to count it on the picture to figure out the answers to those questions, though. If you did 130 take away 60, you would get 70. But if you did 120 take away 50, you would also get 70. So you can subtract them to figure out the answers to those questions. Just make sure you always put the bigger number first, because you're not going to ever get a negative number with an angle, at least in this class. So for angle NLP, it's 70 degrees. And so you can get that by doing either 130 take away 60, or you can get it by doing 120 take away 50. And so just make that note on your paper so you know that it works for both of them. The next one says you're going to find NLQ. NLQ. So notice how Q ends on an end. The 0's right here. So if I'm finding out how big angle NLQ is, I could use the outside, but it's faster to use the inside. So I'll start at 0, and then 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So the measure of angle NLQ is going to be 120 degrees. And then the last one for this one says MLQ. So MLQ goes right across the bottom. It's a straight angle. It goes from 0 to 180, 180 to 0. Anytime you see a straight line, you automatically know that it's going to be 180 degrees. So for the next one, I'm going to zoom back out a little. Just give me a second to get this set up straight. So for example number, let's see. For example number 4, the directions to the question want you to start by plotting these points on the graph. So A is at 1, 5. So there's point A. Point B is at 2, 1. So here's point B. And then point C is at 6, 2. And so there's point C. Let's double check and make sure I put my points in the right spot. The directions to the question say draw in angle ABC. They give me this order, which means I'm going to draw in the angle with B as the vertex. And the only way that you would know to do that is because of the order that they give you the letters. If they said angle CAB, then I would be connecting them in a different order with a different angle. They want us to find the measure for the angle. So you can look at this pretty quickly and take a look and see that it looks like it's just going to be about 90 degrees. You could confirm that by using a protractor if you had a protractor of your own. You can also confirm that it's a 90-degree angle by looking at these slopes. Something that we haven't talked about in our class yet is that the slope of this line, it's down 4 over 1. So the slope of this is negative 4 over 1. And then from here to here, the slope is up 1 over 4, 1, 2, 3, 4. So since the slope of this line and the slope of this line are opposite, one's positive, one's negative, and they're also reciprocals, one's the flip-flop of the other one, that means that they're perpendicular too. But you don't have to know that for this class. What you can tell is if you took the corner of a piece of paper and if you lined it up, it looks like it's almost exactly perfect. So we're going to say that the measure of angle ABC is approximately 90 degrees, and that's what the question wanted us to answer. All right, so for the last example in the notes for today, you're asked to use a protractor to measure the angles, and then you're going to say what kind of angles they are. So you don't have a protractor yet for the course that you're enrolled in. So what I'd like you to do for this one is you're going to go ahead and just write down the numbers as if the angles were given to you. So I've already measured these with a protractor, and I just want you to copy down the answers. So angle AFB, when it's measured with a protractor, is about 50 degrees. Angle AFC, when it's measured with a protractor, is approximately 75 degrees. AFD is approximately 150 degrees. BFE is approximately 130 degrees. DFB is approximately 100 degrees. CFD is approximately 75 degrees. And then AFE is approximately 180 degrees. And so since you don't have your protractor yet, you can't answer this question where they're asking you to measure it using a protractor. Now that you know how big the angles are, though, you should be able to go very quickly through these and circle whether they're an acute angle, whether they're an obtuse angle, whether they're a right angle, or whether they're a straight angle. So any angle that's between 0 and 90 degrees is acute. Any angle that's exactly 90 is right. Any angle that's between 90 and 180 is obtuse. And any angle that's exactly 180 is a straight angle. So 50 is acute, 75 is acute, 150 is obtuse, 130 is obtuse, 100 is obtuse, 75 is acute, and 180 is straight. So in this picture, the only example that you weren't given was an example of a right angle. A right angle would be if the angle was exactly 90 degrees.